So this is January 2022 paper, and question number 1 says that explain why the first ionization energy of aluminium is less than the first ionization energy of magnesium. So if you remember aluminium and magnesium. So magnesium is 12 and aluminium is 13, right? Magnesium is
Hmm.
12 and aluminium is 13. So if you can see the electronic configuration of magnesium, it's gonna be it's ending on 1s2, then 2s2, then 2p6, then 3s2, and that's it, isn't it? This is magnesium, right?
Yeah. Hmm.
And then we have 1s2, 2s2, 2p6, 3s2, and then 3p1. So what can you say after looking at this one, why the ionization energy of aluminium is lower?
Aluminum is more unstable compared to magnesium.
Uh,
Like
Less stable. Why less stable?
because the valence shell is not like not the valence shell. Sorry, the orbital is having only one electron. It's not half filled. It's not partially filled or full filled. So or fully filled.
Yes.
So
So we can say that this is number one, it's a partially filled.
hmm. Partially
And
filled.
whether it's a partially filled, and I can say that it's further away from the nucleus.
So greater atomic radius.
Exactly. Further away from the nucleus, less nuclear attraction. Less nuclear attraction. So that's the reason I can say that less energy would be required
Okay.
to remove electron. It's fulfilled. It's more stable.
Which one? Discuss which one? Oh yeah, fulfilled,
3s2.
closer to nucleus,
More energy required.
higher nuclear.
Exactly.
Yeah.
So, of course, more energy would be required to remove outer electron of magnesium. So that's why ionization energy is higher. Remove electron. So explain why the first ionization energy of sulfur. Why the first ionization energy of sulfur is less than the ionization energy of phosphorus.
So sulfur would be 3p4, which means that sulfur has spin pair repulsion, which makes it more like you know unstable, I guess. So there's like more repulsion. That would be one mark, spin pair repulsion, and the other one would be um, further away from nucleus, less nuclear attraction, less energy required to remove the electron, like how we had written for
Yeah,
the previous
exactly.
question, right?
Yep. So sulfur is 16 and phosphorus is 15, right? So 15 means
Hmm.
that it's gonna be 3p3 and sulfur is 3p4. Yes. So I can do this one like phosphorus is going to be 3p3 and sulfur is going to be 3p4. 3p3 means it's half filled,
Okay.
more stable, no spin pair repulsion,
Hmm.
no spin pair repulsion, more energy required. P4 is partially filled.
Okay.
There would be spin pair repulsion. To remove electron. Identify the element in period 3 has the highest third ionization energy. Like in period 3 starts from sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Then, how can we say that in the third period? You can check the periodic table, what it should be.
Uh, Identify the element in period 3 that has the highest ionization energy. Um, would that be sodium?
Sodium. No,
Highest ionization energy, yeah, in period 3, sodium.
no, it's not sodium.
Okay, wait. Then maybe like chlorine or something?
Chlorine. No, basically what they are saying that
Argon.
third ionization energy. So it's
Oh,
mean
third
that it
ion.
should be in group 2, isn't it? It's mean that it should be in group 2 because those elements which are in group 2, they can remove their two electrons very easily, but when you will be removing its third electron, it would be very, very difficult to remove the third electron because you know they have three shells. So in the third shell, I'm talking about magnesium. In its third shell, there are two electrons. When you will be removing two electrons from magnesium, so of
Right.
course the shell, so after removing two electrons, how many shell would be remaining? I can say two. So
Mhm.
therefore, when the number of shell decreases, so atomic radius decreases, force of attraction increases, so more energy would be required to remove the third electron. So
Makes sense.
that's why it should be in group 2, right? So I can say it's magnesium.
Yeah. I didn't read like the third ionization energy part. I can't skip it, my bad. Okay.
Yes.
Um,
Explain the decrease in atomic radius of the elements silicon, phosphorus, and sulfur.
silicon. Um, so it decreases from sulfur to silicon, and that's because
Silicon is 14, phosphorus is 15, sulfur is 16. We are going from left to right, and this is in period 3.
yeah, but look, the um molecule, like the sorry, the element is getting larger, right?
Why larger?
Because there are more number of electrons that are being added.
Oh, they are not talking about the ions. They are talking about the simple element. That they are saying elements, not the
Also, you talk
ions.
about protons and the nucleus.
Yep.
Um, so due to more nuclear charge, it's the force of attraction towards the nucleus would be stronger. So
Okay.
atomic radius decreases as number of protons increases.
And what do you think about the shielding? Like, is this increases or decreases or remain same across the
Remains
period?
same because period.
Yeah, exactly. So I can say that
No shielding effect.
more
And
protons, or I can say that the number of proton increases, number of protons increases Nuclear charge increases and shielding
Effect remains the same or doesn't
remains
change.
same. When the shielding is the same, that's why I can say that the nuclear charge increases. That's the reason. The
Alright.
question is about fluorine and its compound. State the meaning of the term electronegativity.
Um, Electronegativity is the um like the ability of ability of a element to like gain electrons, something like that.
Yeah, exactly. So we can memorize it as it's the reverse of ionization energy. If ionization energy is the loss of electron, so electronegativity would be the gain of electron. And in fact, in ionization, we can remove one electron. In ionization, we can remove one electron, but in electronegativity, it's not the gain of only one electron. It can attract the pair of electron. And also, it's mandatory that we can define electronegativity in terms of a covalent bond. It's not like a gain of a single electron. No, it would be something else. It would be known as electron affinity. There is a difference between electron affinity and electronegativity. So I can define it as ability of an atom to attract shared pair of electron towards itself in a covalent bond. Like I
Yeah.
can say I have HCl. So since chlorine is more negative, so chlorine has attracted the electron of hydrogen towards itself. Since this is more electronegative, this is called electronegativity. Okay.
Hmm. All right.
Yeah. Draw the shape of SeF2 molecule and a SeF4 molecule include lone pair of electrons that affect the shape of the molecules. SeF2, we have to count the total number of electron pairs, including lone pair and bond pair. So Se, then I have, hopefully it would be having selenium is in group 4, I think so, isn't it? Selenium.
Selenium
See the group number?
is in
What's the group number?
it's in group six, six, six.
Yeah, group 6, selenium.
Yeah.
Yeah, okay. So means that it's just like oxygen.
SCF2, right?
It's just like oxygen. Yeah, it's just
Yeah.
like oxygen. So selenium is going to be 1, 2, 3, 4, 5, 6. Then I have fluorine like that. So I can draw in this way.
Okay. So they're gonna be
It's
like
a bell
two
shape.
lone pairs, right?
Exactly.
Yeah. Two.
2 LP, 2 BP. And
Yep.
SEF4, of course, it's a 4 bond pairs, and of course, it's gonna be one lone pair. Yep. So
Yeah. One lone pair and four lone pairs.
Okay, so it has one lone pair and three four bond pairs. Van der Waals forces exist between molecules of SEF2. Explain how these forces arise. Explain how these forces arise.
Um, how do they arise? What do they mean by how do they arise? Like how do they come or
Okay,
something?
Van der Waals force or a London force is also known as a ID force, and these forces arise due to like when the molecule is non-polar, because in a polar molecule there is you can say permanent dipole PD forces. So of course London force or a van der Waals force arises, it's due to the repulsion of electrons, of course, because these are also known as induced dipole. So it's of 3 marks. So first of all, I can say that, let's say I have, this is the first molecule of SEF, this is the second molecule of SEF2. So they are talking about this attraction, because van der Waals force is a type of intermolecular force of attraction, means that these are present between the molecules, not in the molecule, it's between the molecule. So hopefully it would be like partial negative and then partial positive, then partial negative, partial positive. So due to these
Okay.
partial positive or partial negative charges, there would be a force of attraction between the two molecules. It's known as induced dipole. But when this molecule would be single, so there would not be any charge. It's a non-polar one, right? It's a non-polar. Let's say this is a good example to understand. Like let's say I have bromine and bromine. When this is single, so I am not supposed to write partial positive and partial negative. When this is single, because single it's non-polar. But when the two bromine molecules will come close to each other, so of course they will be repelling each other because both would be having electrons. There would be repulsion between electrons. So due to the repulsion, there would be unsymmetrical distribution of electron after the repulsion, not before repulsion. So after the repulsion, there would be unsymmetrical distribution of electrons. So due to that unsymmetrical distribution of electron, the compound would become polar. Like on the first bromine, we would be having partial positive charge, and on another bromine, we would be having partial negative charge. So same goes for SEF2. Same goes for SEF2. As when the two SEF2 molecules come close to each other, okay, so then I can say that dipole induces, it would be creating a dipole. Like this molecule would be creating a dipole into another one. Or you can consider this one, like this molecule is going to create a dipole in another molecule. So due to the dipole, there would be attraction between the partial positive and the partial negative charges. So that's why it's known as van der Waals force. Okay.
Okay.
Yes. So how you will be writing the answer for this question? It's of 3 marks.
They come in like non-polar, like attraction between two non-polar elements or something. And
Basically,
yeah.
in the first molecule, movement of electron, so it creates a dipole into other molecule into another molecule and induces partial positive and partial negative charges. So there would be attraction
What does dipole mean again?
between the opposite charges. Charge.
Okay.
Di means to, pole is the charge. Like HCl means H is going to be partial positive and Cl is going to be partial negative. It's called dipole is created. It was not polar by birth. It was not polar by birth, but when the two molecules join together, it becomes polar due to the force of repulsion between the two molecules.
Okay.
Explain how a lone pair of electron in a molecule of NF3 affects the bond angle in the molecule. So it's related to electron pair repulsion theory. It's related to electron pair repulsion theory.
Okay. Um, like the lone pair is the most repulsive. Like it's going to cause the most repulsion between the other pairs. So that's right.
Yes.
But
Basically,
I don't know.
we should know that repulsion criteria, like repulsion between lone pair and lone pair is greater than the lone pair and bond pair, and this repulsion is greater than the bond pair and bond pair. This is the criteria for repulsion, and the shape of a molecule sets itself in such a way that there would be minimum repulsion and maximum attraction, because those molecules or a compound are stable, which is going to have less repulsion and maximum attraction. So that's why those molecules which would be having more electrons, so there would be more repulsion, so then they will be stabilizing their self to minimize the repulsion. So of course the bond angle would be changing. So that's why they are asking how a lone pair of electron, of course on a nitrogen atom we have one lone pair of electron, affects the bond angle in the molecule. So I can say that uh, lone pair, I can say that lone pairs repel the bond pair. Lone pairs repel the bond pair, that is just like that. NF3. I'm talking about this repulsion. I'm talking about this repulsion. So they will be repelling each other. As a result, it will be shifting like that. So I can say that bond angle will decrease. Boron reacts with fluorine to form the compound BF3. Boron is a solid at 298 Kelvin. It's mean that at room temperature.
Hmm.
Write an equation including state samples for the reaction that has had an enthalpy change equal to the standard enthalpy change of formation, that is BF3. So they are asking to write down at standard condition. They are writing about the standard condition. So they told us that bromine is solid. So I can write boron that is solid at room temperature is reacting with the fluorine, that is F2 is a gas at room temperature, and then it's gonna form BF3. They told us that this is a gas. I am supposed to balance the equation, so what should I write?
Um, think on the left hand side you can write 3 with F2, and on the right hand side you can write 2. And with bromine you can write
No,
2 on
if
the
you will
left hand.
be if you will be writing 2 over there, so you will not be getting
Hmm.
any mark because they are talking
No,
about the
on the
standard
left hand,
enthalpy change.
then you can write half or something, or like not half, but
3 by 2, I can
uh,
write, or 1 and 1 and a half. It's equal to 3 by 2.
you will write 3 over 2.
Yep,
No, no, okay, yeah, that's fine. But on the right hand side, if you write 2, and on the left hand side
it would
with
be wrong.
bromine, you write.
Right
No,
hand side, you
listen,
are not allowed to put any number.
oh, you're not allowed to put any number. Oh, okay.
Yeah, exactly. This is a standard.
Okay, I didn't know that. All right. So 1.5 there, and okay, got it. Okay.
Okay. See this one?
Yeah. B is boron, yeah. Right. Okay. So there are in BF3 there are 3 bond pairs and no lone pairs.
Yeah. 3 bond pair, 0 lone pair.
Hmm. So the bond angle is 109.5. No, it's 120.
Mm.
Right. No lone pairs. Right. Okay.
And how the bond is formed?
Um. What do they mean by how the bond? Like, I don't get it. What?
They're asking how bond is formed.
What do they mean by that? Like they're just formed.
So is this a covalent bond or not?
Yeah, it is a covalent bond.
They are saying BF3 molecules are trigonal planar. A molecule of BF3 reacts with a fluoride ion to form BF4 minus ion. State the bond
Hmm.
angle in BF3. Describe how the bond between BF3 molecule and a fluoride ion is formed.
Okay. All right. Got it. So I think that when an electron is added to like the BF or something, like when it becomes an ion, then it has an extra electron for the fluorine to be, attached to or something. Like I did not explain. What did you write? Can you explain it?
Basically, fluoride ion is donated a lone pair to the boron.
Oh, okay. Right.
See, this-
Okay. So um, KF is ionic bonding, whereas IF is, I think, what is IF? Non-metal and non-metal. So covalent bonding. So ionic bonding is of course more stronger compared to covalent. So the ionic bonding has like a higher temperature. I can say that. And what else? Yeah, what else could I write here? Like, what else could I talk about?
Potassium fluoride, it's an ionic bonding, right? Ionic compound.
I said that here.
Or iodine fluoride. Or iodine fluoride. It's an ionic or a covalent.
Covalent.
Explain in terms of structure and bonding why the melting point of Kf is higher than the melting point of If. So I can talk about the structure of an ionic compound. I can talk about the structure of a covalent compound. And this covalent is simple molecular or a giant?
Which one? I think it's simple. I don't think so. It's done. No.
Yes. So I can say, that Kf is ionic compound having giant ionic lattice structure, in which many ions are present, due to which there would be strong electrostatic force of attraction, Shh. electrostatic force of attraction electrostatic force of attraction. That's why the melting point of Kf is higher.
Okay. All right.
And what will be the points of covalent?
Um, Covalent bond. There is weak intermolecular forces of attraction,
Okay.
and uh, and it is a simple structure. It's not a giant covalent structure.
I molecular structure, simple molecular structure, and there would be a weak force of attraction.
Yeah.
Okay, see this one?
Yeah.
It's easy, right?
Yeah. Yeah. 1s2, 2s2, 2p6, 3s2.
That's it.
Yeah.
Proton number is 12, right?
Yeah, magnesium, yeah, 12.
Magnesium is used in the extraction of titanium and metal from titanium fluoride. Write an equation for this reaction.
Okay, so Mg plus, what's the titanium's thing formula? Mg plus what's titanium's Ti? Mg plus Ti, that's 4, yeah. So TiC4, Cl4, Mg,
TiCl4 plus Mg. It's
and
gonna
then
be
iron.
MgCl2 and
Yeah.
titanium is separated, right?
Yeah. With why can't it be MgCl4 by the way? Like oh yeah,
Mg is in
because it
group
does.
2, right? So the charge is
Right,
2.
right, right. But now you'll have to balance it, right? So you can write 2 on the right hand side and then yeah, 2 there. That's balanced.
A sample of magnesium reacts completely with an excess of hydrochloric acid to form hydrogen. Calculate the mass in grams of the sample of magnesium. Give your answer to three significant figures. R is constant, that is this. So, okay. PV equals nRT,
Nope.
where N is the mass
Mm.
over MR.
You can find yeah N over MR, right? And okay.
So
Magnesium's MR
mass
is
is equal
24.
to PVMR, uh, PVMR and RT. So P is the
Yeah.
pressure, that is 101. V is
Times tau
volume, that
media.
is 149 into meter cube. Then I have MR, that is going to be, what's the MR?
Uh, MR is 24.3.
MR is 2. Okay.
MR? How is it 2?
And divided by, because PV is equal to nRT, we are going to find out the, first of all, you have to find out the moles of, first of all, you have to find out the moles of hydrogen. Then you can put
No,
the mole
no.
ratio.
Moles is mass over MR, right? So wouldn't MR be 24.3?
I am supposed to solve it like that. N is equal to PV over RT. Because the data which I am going to put is of the hydrogen, not for the magnesium. So from this equation, we will be finding out the moles of hydrogen, not the moles of magnesium. Isn't it?
Okay, okay.
P is 101,
Hmm.
149, 8.31 into temperature, that is 298.
Yeah.
Yes. Mole of
Now
hydrogen.
this. Yeah. So Mg and hydrogen are both 1 to 1, right? So
Yes.
so the number of moles of hydrogen would be equal to number of moles of magnesium, and To find out the mass, we just have to multiply the number of moles by the MR. The MR is 24.3 for magnesium, and that would give you your answer.
Okay, it's easy.
24.3. But yeah, okay.
24.3. Okay.
Yep. Yeah.
Minimum volume of HCl needed to react completely with magnesium. Now they are asking the volume of HCl.
Um.
Sallallahu alaihi wasallam. What's
So
the
we
answer
have
for
the
what's the answer
mass.
for this one?
I didn't calculate it. 1 second. Can you scroll down? I mean up. I'll just calculate it. 1 second. N is equals to 0.006. 0.006.
Okay.
Now you can use the N equals to CV formula as well.
Then it's gonna be what's the answer?
Um, 1 second. 0.006 times 2 is 0.012. 1, 2, 12. Yeah. And now we have the number of moles. So 0.012 divided by 0.500, I think, which would be 0.024.
0 point.
Yeah, 0.024.
Okay. Okay. See this. Magnesium reacts slowly with the cold water, like Mg with cold water. Cold water is H2O. It's going to produce MgOH2. Would there be any other would there be any other product or not?
Um, I don't think
Because
so.
it's a cold water.
It's cold water, so there would be hydrogen gas, I think, or something like that, maybe. Because like
Uh
not all of it is going to react, right?
Yes.
Not all of it is going to react. So that's why.
Oh, what they are asking, oh my God. They are asking state one use of magnesium hydroxide. They are not
The
asking to write
equation is
down the equation.
no you
So
yeah, you wrote down 0.6.
see this. So one use of magnesium hydroxide. So what can I write for this one?
It's a salt maybe. So
Salt
magnesium
or
hydroxide is a salt, yeah.
basically it neutralizes
An acid.
it neutralizes excess
Hmm.
stomach acid, that is HCl.
Do I have to memorize these uses or what? Because I did not know that.
You have to memorize this.
And where can I find these uses? Right?
Group 2,
Is it in your
periodic
note?
table, group 2. Inorganic chemistry, I have written,
No.
yes.
Okay, all right. No, wait, I
See
haven't done
this
like that part, right? I haven't done organic chemistry.
inorganic, I'm not saying organic.
Oh, okay.
Inorganic,
Okay.
yes. Magnesium hydroxide decomposes on heating to form magnesium oxide. Then
Um, yeah, so it would be the same equation that you wrote, and yeah, nothing else would be added to it because
no,
it's just
they're
magnesium.
asking something else. Read the
Oh,
question carefully. They're
decomposition.
asking something else.
Yeah, decomposition. So you're going to write the formula of magnesium hydroxide, which is MgOH2, and
Exactly.
then you're
It's
gonna
going to
write an
be
arrow, then write MgO plus H2, I think. H2O. Right.
this question is about energetics, okay? Use the data in the table 2 to calculate a value in kilojoules per mole for the enthalpy change of formation of this one.
Is this like the Hess law or something?
Yep. You can directly apply the formula product minus reactant.
Okay. So product would be 3CO2. So multiply 3 by negative 394 and add that to 4 times 286, which will be your product. So let me just do that. So your product would be negative 2326. Can you write that? Negative 2326. Okay. And
I can apply this one.
4 1.5 times. We don't know of O2 either, right? Like what's the enthalpy? What's the sorry? Yeah, the standard enthalpy of formation of O2.
Product is CO2, that is minus 394 times 4 times 3 plus 4 into
The product
286.
2326, negative 2326.
We have to find out
Why do you
X.
write plus zero?
It's a diatomic. All the diatomic elements have a zero enthalpy change.
Wait, so isn't CO2 also diatomic? Oh,
It's
okay,
not a
diatomic as in
diatomic.
like only O2. Right, okay, okay. Got it. I did not know that. Okay. So x will be um 1 second. I'll have to calculate this. 0, 1, 0 plus 2, 3, 5, 2, 3, 2, 6. Uh, 1 second. Is it going to be 316? If I'm not wrong.
316
Can you check if that's the right answer?
minus 2010 plus 394 plus 394 times 3 uh, plus 4 multiplied by 286. So so you are getting which answer?
Okay, for the negative x part, I'm getting 316 for negative x. So x should be like
So it's gonna be
so x should
positive,
be
right?
negative. No, no, like negative x is 36. Oh, okay. I guess. No, because wait, 1 second. When you solve that part, right? Negative x is equals to 316. So shouldn't it be, yeah, negative 316, right? Okay. All right.
Use the data in table 3 to calculate a value combustion of this compound. Use the data in the table 3. Okay, the bond enthalpy means the bond energies are given to you. And of course, first of all, is the equation given in the question? No. Yeah, given. So what we have to do, we have to look at the bond angles, then we have to apply the formula. So then after putting the values, you will be having the answer for this enthalpy change. Since we know that the enthalpy, like the delta H is equal to product minus reactant, but when you will be taking the bond energies, bond length, bond energies, so the formula would be reactant minus product.
Okay.
So then you have to write down the structural formula, and then you have to see how many bonds are present, like between the CC, between the CH, between OO. Then you have to like solve it. Even they have given you the displayed formula of this one, so that you can put the values for the bond energies and then you can solve it.
Uh, what? Okay. By the way, when do you have to use the Hess law, like that stuff?
When he will be asking to draw the Hess cycle, then we can draw this. Otherwise, you can directly solve it.
Okay. Right. So in this case, I'll just have to like do it normally, like add all of them and get the value, right? Okay.
So this is the structure. Combustion is taking place means while reaction with oxygen to form carbon dioxide, and then I have water molecule. Then we have to balance this equation. Number of carbons are equal to carbon dioxide, that is 3. And water would be half of the hydrogen. 1, 2, 3, 4, 5, 6, 7, 8. So this would be 4 water molecules, so 4 oxygen. Four oxygen and three to the six oxygen. Six plus four. 6 plus 4, 10. So we have already one oxygen atom, so we need 9. So 9 over 2. This is the balanced chemical equation for the combustion of this alcohol. Then you can put the, let's say, um, CH 412 multiplied by 1, 2, 3, 4, 5, 6, 7. 7. Then carbon is 348 multiplied by 2. Then I have CO, that is 360. Then I have OH, that is 463. Then I have 9 by 2 multiplied by O double bond O, that is 496. This is reactant side. Minus, then we have to solve the product, that is carbon dioxide, C double bond O, that is 805 multiplied by 3 to the 6. 3 805, okay. Then OH. 463 times 8. OH is 463. This is product side. Now you can solve it, then you will be getting your answer.
Okay. All right. One second. Negative 1899 enthalpy of combustion. I don't know the reason that it's different.
Don't know
Why
the
is it
reason?
different?
What do you mean?
Like, why is it different?
What
In
different?
wait, can you show me the question again? Maybe show me the question again. Or it's 4.2, right? Second. Um, there's enthalpy of combustion and there's enthalpy of formation. So in one there it is forming, in one there is. Okay, wait, no. Like 4.1 was enthalpy of formation. Then 4.2 is enthalpy of combustion. So
Mhm.
saying different value used. Um, I don't know. Like it's negative 2010 in that, and here it is negative 1899. If I'm not wrong. No wait, that's different.
Yes,
Yeah,
answer is correct.
what's correct?
The answer is correct, okay.
What answer is correct?
Oh my God, this one.
Yeah,
1899.
yeah, that's correct. No,
So just two
I don't know
reasons.
4.3. I was on 4.3.
So just two reasons why the value for enthalpy change of combustion of propane 1 all calculated in 4.2 is different from the value used in question number 4.1. So 4.1 is this, that was minus 316. So they
Hmm.
always ask this question and the answers are always same. We always write that the answer is different because the bond enthalpies are the average bond energies. They are the average bond energies. And for the enthalpy of combustion, we take the enthalpy changes for the gaseous ones. And in the formation, we take their standard states. and we take their standard states basically. So obviously we would be getting the different values. So reason one, I can say the bond enthalpies are average. Bond
Enthalpies are
enthalpy
average.
is average bond energy. Reason two
Okay.
is that bond enthalpy,
Bond enthalpy is average in what, like in 4.2, 4.1? And
this one. These values are average.
because it's enthalpy of combustion.
Yeah. Bond enthalpy
Okay.
calculations are for the gaseous. Okay, 3 marks. Okay.
Um, do I have to use a specific heat formula like the M over C? Was it, what was it? C
Q is
something.
equal to MC delta T.
Yeah, Q is equal to MC delta T, and there was another formula, yeah, which had the moles or something, I think. Not sure. But anyways, Q equals to MC delta T. We have the C here, which is 4.18, right? And energy we have to find. No, we have to find mass. And temperature is going to be the change. So 319 minus 296, which is 23, is our change. And how will you find the energy? Oh, energy is like the, no, we have been given for proper knowledge. The energy.
What's the answer did you get?
Um, yeah, I'm confused about what would the energy be.
250 times 0.18 delta T difference in temperature. That's gonna be, yes.
Oh wait, so I have to find the energy. Okay. Oh, 1 second. Uh, the answer that I'm getting is 24035.
24035 joules. Then what we are supposed to do? You are supposed to convert it in kilojoules. The answer would be what?
Yeah, with the 24035 is the answer for the one that you wrote. Wait, you're going to multiply by
Kilojoules.
what?
Divided by 1000
Wait,
from joule to kilojoules.
okay. All right. Yeah, that's what you wrote exactly. Yeah. And then after that, what are you going to do? This is not the final answer, is it?
Yes. So they have given you this value, that is this. Mole of propanol would be equal to this value. It's gonna be 2010. What's the answer? It's in kilojoules. It's in kilojoules. So when I will be dividing these two values, kilojoule, kilojoule will be cancelling out. So I would be getting the moles.
What?
Yes.
But you just cancel out the units. How
Yeah,
does that
exactly.
work?
Basically, they are asking to find out the mass. So before finding out the mass, we need to have the moles. So what I do, I have this value is given, and I know that the unit is kilojoules per mole, and the one that I have calculated is in kilojoules. When I would be solving these two values, first unit is kilojoules, another one is kilojoules per moles. So the answer would be after cancellation, I would be getting the moles.
You can cancel out the units?
Yeah, I'm dividing it. Of course, automatically they will be cancelling out.
I mean, why are you writing the units there in the first place?
I have used this value. It's in kilojoules per mole, right?
Wait, 1 second. What's the formula here? You wrote mole of propanol, right?
Yeah.
And then that's equal to like what's the formula?
Basically, there is no formula like when, if you remember in the mole questions, generally sometimes they give the density as well. Sometimes they give the density as well and the volume as well. So what we do, we can find out the mass directly. We can use the formula density is equal to mass upon volume.
Okay,
So grams per decimeter cube, when it will be multiplying by the volume that is in dm cube, they will be cancelling each other. I would be getting the mass, isn't it?
right.
So same goes over there. They have given as the value for the delta H that is in kilojoules per mole, and I have the value that is in kilojoules. I have to solve it in such a way that I would be getting the moles. So now it's up to you using these two values how you will be finding out the moles.
Okay, all right.
I can say that 210 no 2010 is the number of mole that is in is the num is the kilojoules energy in 1 mole in 1 mole. So if I have this one energy 24.035, so what would be the answer?
Your I can't see your screen.
So using this,
Yeah,
how
one
can we
second.
find out the x?
Cross multiply. So 24035 divided by 2010.
So I did the same thing. Okay.
Yeah,
You
but
can
like
do it
I
directly as
was
well. So
confused
next,
how you
what's the
cancelled
answer?
out the units. Okay, answer 1 second. 2010.8. No, sorry. 245. The answer is 0.011, 0.012. Yep.
It's the mole. We need the mass.
Yeah, if you have the moles, then we can do moles multiplied by the MR of propanol. They probably have given it in the question,
M
right? No?
60.
Yeah, 60. So, yeah, 0.012 times 60 would be 0.72.
Yes. Bromine is an oxidizing agent. State in terms of electrons the meaning of oxidizing agent. In terms of electron, whether they lose electron or they gain electron, oxidizing agent.
Um, Oxidizing agent itself is reduced, so it gains electron. Okay.
Write a half equation for the oxidation of SO2 to SO4 2 minus. Okay.
Um, SO2 arrow SO4 plus 2E. No, wait, two electrons are going to be added on the right hand side, yeah, because they're. No, why are you adding two electrons to the right hand side again? Why not to the left hand side? Because if they're added
Because
onto
they
the
are
left
going
hand
to,
side,
basically they are saying that oxidation is taking place and oxidation is the loss of electron. When the species loses electrons, so we are supposed to write on the left and on the right hand side. And
yeah,
else you can
okay, but
balance this equation.
okay. No, I get that, but like my confusion is that like if you add it on the left hand side, yeah, the two electrons, then that would mean like when you're giving two electrons to SO2, SO4 is going to be like two more electrons or something. That makes sense. Maybe never mind. Okay.
Basically, then you have to balance this equation as well.
Okay. How do you balance it then?
The same criteria that we did, oxygen is balanced by water, hydrogen is balanced by hydrogen H plus, then charge is going to be balanced 0 0. This is minus 2, this is plus 4. Plus 2, I have to balance the charge, so I'm going to write 2 electrons. So I can say that minus 2 plus 4 and minus 2 is 0, and it in the reactant side it's also 0.
Okay.
Yes.
All right.
Write an equation for the reaction of bromine with aqueous SO2. Explain using oxidation states how bromine oxidizes SO2 to SO4 2 minus. Uh, Write an equation. This is SO2 and this is SO4 2 minus. It's reacting with bromine and bromine will be
Okay.
converting into the bromide. because bromine or reduces itself when it oxidizes other one. It means that it reduces itself into Br0 to Br minus 1. 0 to minus 1 is the reduction. Then we have to balance this equation. So I'm supposed to write 2 water and 4H plus, and Br should be balanced. Then electrons are also, let me check, 0, 0, 0, minus 2, and plus 4. Yeah, this is going to be 0. Yes. So this is a balanced chemical equation.
Yeah. Okay. All right. Makes sense.
Explain.
And what about the explanation?
Uh, then we can say that what's the oxidation number for sulfur in this SO2?
Uh, SO2 oxidation number. So negative, positive 4.
Okay, positive 4. And what about in this
In what? What about in what?
SO4?
SO4 sulfur. I'll have to calculate this 1 second. X plus negative 2 times 4 is equals to negative 2. Sulfur is 6, positive 6.
And this is 0. This is minus 1, right?
Uh, yeah.
So sulfur is oxidized. While Br2 is reduced.
Hmm.
A few drops of aqueous bromine are added to a test tube that contains some sodium iodide solution. State the color change observed in the test tube. Write an equation for the reaction. Bromine aqueous. Bromine aqueous
Um,
is reacting with
it can be from
sodium
colorless
iodide.
to red brown. Red color change can be red brown to colorless or the opposite, something like that.
This is type 2.
What?
This is going to be aqueous, or I can say iodine is also aqueous. So color change would be basically in the product side iodine is being formed. So for the iodine, I can write that this is brown solution, or I can say this is a black solid, or I can say that this is a black solid. And in the product reactant side, it was Br2. Okay, so or I can say that colorless solution to brown solution. Colorless solution to brown solution. Colorless solution to brown solution.
Okay.
6.1. Give the meaning of the term mass number.
The number of uh, the nucleon number, the number of protons and neutrons in the nucleus of an atom.
I can say it's the sum of proton and neutron, isn't it?
Yeah.
I can say it's the sum of proton and neutron, yes. Okay. The most abundant isotope of argon has a mass number 40, then 39, or justify why argon is placed before potassium in the periodic table, but do not refer to the chemical property. Okay. Elements are arranged in the periodic table according to their proton numbers. Elements are arranged in the periodic table according to their proton numbers, right? So how can I explain this one?
Uh, how will you the most
They are saying
yeah.
they are saying that in the periodic table, argon is potassium is 19, argon is 18. Okay,
Hmm.
argon is 18 and potassium is 19. But potassium is 40 and argon is potassium is 39 and argon is 40. Okay, so argon has a greater mass. So it should be after than potassium. But in
Oh,
the
I know this.
periodic
I know
table,
this. I think it's because it's not like because of the mass or something. It has to do with something else. Uh,
yeah, in the periodic table, elements are arranged on the basis of their proton
Proton
numbers,
number.
not the mass number, right?
Exactly.
Exactly. So I can say that elements are arranged in of order of proton number. In order of proton number, right? So uh, okay. Or it's of 2 marks, right? So potassium has 19 protons and argon has 18.
Okay.
So potassium has one more proton than argon. That's the reason argon is placed before magnesium, before potassium.
All right. Okay.
A sample of argon is analyzed in a time of flight mass spectrometer. The first stage is ionization of the argon atoms by electron impact. Write an equation, right, including state samples for this ionization.
Um, can say that. 1 second. So do after that the
Species
first
should be
ionization? Okay. Yeah. Or they should all be in gaseous form.
exactly.
And yeah. then that. And Right, yeah, okay. Right. So here I just have to like substitute them and make it the subject and find out the answer.
Yeah.
So I'll just do that. 1 second. So I have to find the kinetic energy. Okay. Can you scroll up so I can see? No, not that though. Like down there. Yeah, yeah. To get the mass of argon, I'm just going to do 40 times the Avogadro's constant, right?
Yes.
Or 40 divided by the Avogadro's constant.
So what they're asking in this one, kinetic energy. Okay.
So do I divide it or do I multiply it?
You can multiply. And by the way, we can get the direct answer. Like I can say that they're asking to find out the mass in kilograms. Okay, so let me separate the mass. That is gonna be T square.
I've like already gotten the. Yeah, okay. You'll have to like make it a subject and yeah. That's
Right?
hmm.
Or okay. Or I can say mass is equal to time that is given to you. What's the time? 1.25 minute. 1.25 raised to the power 2 times kinetic energy. That is gonna be no. Yeah, okay. It's a that length is
Your voice is cutting out.
now.
Yeah, that's fine. Wait, I'll just get a paper. I'll do this.
Okay.
Like I tried finding it out on my calculator, but then it wouldn't give me the right value. So I'll just do it here on a paper. Just make it the subject and find the answer. I've done this question before too, so 1 minute. Sir, can you scroll up? I want to see what the time is and all. Sir? Yeah.
Yes.
Yeah, nothing. Okay. Is the answer like 4.7 times 10 to the
No,
power of 32?
no, no, no.
Did I have to divide? Wait, 1.29 something?
Answer is 1.3 exponent minus
Uh,
18.
yeah, so my mass is not right. You said to multiply 40 by 6.22 to get the mass.
1000 multiply. Yeah, okay, 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 okay. This is mass that is 40. Okay. Basically, we are going to find out the mass. This is an MR. Okay. So mass is equal to
Hmm.
like the MR divided by the Avogadro's constant. You have to multiply this by 1000 to get the mass in kilograms. Multiply by 1000,
Okay, got
or
it.
else you can get it directly, and then after finding out the mass in grams, you can solve it. Same thing.
Okay, okay, okay.
6.64.
Can you check the um
To exponent minus 4 seconds square.
I am getting 1.2, 1.3 times 10 to the power of negative 18
Yeah,
for the
exactly. This is what.
kinetic energy. I just did, yeah. Okay.
Okay. Which statement is correct? A sample of argon that contains this one and this one is analyzed using a TOF mass spectrometer. Which statement is correct? The kinetic energy of the AR plus 338 ion is greater than the kinetic energy. Kinetic energy is related to the mass. Okay. So when the mass number is higher, so the kinetic energy is lower. So then they are saying the kinetic energy of the argon 36 is the same as the kinetic energy of the argon plus 40 ion. The kinetic energy of the is less than the, okay. So basically the charges are same, right?
Hmm.
Basically the charges are same. So when the charges are same, so it's mean that the kinetic energy would be the same. So it's gonna be
Okay.
correct.
Why is the kinetic energy being dependent on the charge, by the way?
Like if you remember when we were doing mass spectrometry, so we just drew the ray diagram in which I told you that we have magnetic and electric field over there, and this would be there was some disk, hollow disk,
Okay.
which was having a negative charge. So this hollow disk is going to attract the charge, of course, whether the charge is +1 or +2 or +3. And of course, by the magnetic field and electric field, these fields are going to attract the charges. So when the charge would be the same, so the attraction would be the same, so the kinetic energy, or I can say the speed, would be the same. So it's all about the +2 charge means there would be stronger attraction, so it would be traveling in a more faster manner. And if we have the less charge means the less attraction, and if we would be having a less attraction, so means that there would be a lesser kinetic energy of that particular ion.
All right.
This is of 3 marks. Then you have to calculate the number of the other isotope in the sample.
You have to what? Mass number of the other isotope in the sample?
Yeah,
No.
relative mass they have given to you. That is
Yeah, yeah.
39.964.
Okay. And the relative abundance, no, the abundance is 99. So the other one is like 1 point something?
You can subtract it
Like
from 100.
0 point, yeah. 0 point something.
40 times
That's going to be,
99.090
if you subtract it, it's going to
plus
give you 0.91.
x times I have subtract from 100.
Yeah, that's going to be 0.91, the subtraction part. Can you like explain how you did this part again? by the way?
Basically, I have
Like,
applied this formula. AR is equal to isotopic mass multiplied by abundance divided by the total abundance. So AR is given to us. I know the isotopic mass of this, that is 40. I know the abundance of this, that is 99. I know the isotopic mass. I have to find out the isotopic mass. So I told that this is X, this is X, and I don't know the percent abundance. Since the percent abundance is always from the hundreds, if I knew one, I can find out the another one. I have subtracted this from 100, and then I would be finding out the value for the X. That would be the mass number of the another isotope.
okay, all right. And the answer would be 36.04. 36.04.
36.04.
044. Yep.
Test tube reactions can be used to distinguish between the pairs of colorless solutions. Identify a reagent that can be used to distinguish between aqueous solutions of sodium sulfate and sodium nitrate. Give the observation that would be made in each case, reagent and observation with sodium sulfate. Of course, it's having sulfate, so we are going to write barium chloride. It would be reacting with the sulfate, it would be giving us barium sulfate. So we would see the white precipitate of barium sulfate. So reagent, barium chloride. After adding barium chloride, I can see the white precipitate with sodium sulfate due to barium sulfate. Then observation with
Okay.
sodium nitrate. Of course, sodium nitrate would not react with barium chloride, or I can say I would be getting the colorless solution because there is no
Okay.
observation. So
Sodium nitrate won't
no
be reacting
visible
with barium
change.
chloride. Why is it not going to be reacting, by the way?
Uh, or else I can say everything would be colorless solution. Sodium nitrate and also the barium chloride. Let's say if I say sodium nitrate, that is NO3, and we have a barium chloride, right? So they are gonna give us chloride and barium nitrate, right? So everything is aqueous. There is no color because nothing is the transition element. So that's why with no visible change. I can't see any observation in this one. Or else you can write or colorless solution.
Okay. So barium nitrate is colorless, basically.
Yep.
Okay. All right. Potassium carbonate and potassium hydroxide. Uh, what reagent can be used? Um, they're saying potassium hydroxide. One second. Uh, Potassium carbonate and potassium hydroxide. So carbonate
Identify a
can be like,
reagent that can be used to distinguish potassium carbonate and potassium
yeah,
hydroxide. Okay.
you can add any acid and check for the carbon dioxide gas. You can do that.
Yeah,
Add
I can
any
add
dilute
HCl.
acid. Add any dilute acid.
Observation with yeah effervescence due to the formation of carbon
Effervescence, exactly.
dioxide or with potassium hydroxide. Because HCl,
Mhm. No visible change, right? Okay. And for the other one, next
solution
part
of
we can,
ammonium chloride contains ammonium ions. Okay.
yeah, you can say that you can what did they say? Ammonium chloride. One second. One second. Describe a test tube reaction show that ammonium chloride contains ammonium ions. Ammonium chloride contains ammonium. Um, can we say that add aqueous sodium hydroxide and ammonia is produced if you warm it?
Yes, and we can check ammonia by using litmus paper, right?
Right.
So add sodium
Let me.
hydroxide.
You can just say that ammonia is produced on like warming. Oh yeah, so you're saying use a litmus paper to see, and it's going to turn
And
from
warm
red
this.
to blue, I think.
Yes, ammonia gas formed, which will turn red litmus blue, which would turn red
Right.
litmus blue. Some acidified silver nitrate is added to separate. Okay, okay, okay. Unknown potassium halide. Yellow precipitate. Yellow means that I got Ki, no? Iodine. And formula of Q, colorless solution is seen. Silver nitrate is added to separate aqueous solutions of two unknown potassium halides. Give the formula of an acid that can be used to, of course, we generally add nitric acid in these tests, test for halide ions. And give the formula of an acid, okay.
Colorless. Colorless means it's not
What
an
about
halide or
Q?
something. What
No,
about?
halides are generally colorless, like in the solution. NaCl, NaBr, NaI,
No, no,
NaF, they
like
are colorless.
halide. Yeah. No, I mean like as in
Yes.
halides,
So I
it
can say
is
that's gonna be fluoride, Kf. Because KCl gives like it would be giving you what can I say, white
yeah, yeah,
precipitate,
you're right.
and KBr cream precipitate, and Ki yellow precipitate, then that's gonna be Kf. That's why they are giving us colorless solution.
Exactly. Because chlorine is white, so like anything more reactive than chlorine would probably be, as you
Yeah,
said,
white, exactly.
colorless. Yeah.
Okay.